Hey everyone, welcome back. We're going to continue on with the light bulb application by doing a little bit of refactoring. We're going to introduce smart and dumb components. So in a nutshell, a smart component is a component that gets things through dependency injection and can perform side effects so they can change the state of your application. A dumb component is a component that does not get things through dependency injection and only receives data through inputs and emits things through outputs. And usually these are things that are tied directly to some kind of UI functionality that you might want to reuse somewhere else. So a dumb component can be considered a black box. It just has inputs, emits events, and you can plug them into different applications or different pieces of your application in different contexts. Before I get started with that, though, I want to show a pull request that Brahm, aka Beeman, submitted. He showed me a better way of detecting when the pop-up window gets closed. So before we were using this set interval where we're just checking every 500 milliseconds to see if the window is still open, and if it's not, we could say, okay, it's closed now. But there's this on before unload function that you can define right on the window itself that will fire just before the window is closed. So as it's unloading its resources. So we can actually react to the pop-up window closing instead of relying on a check. So I'm going to copy this right into the app and show you how it works. So that was in the light bulb component. So he suggested I remove this function and replace it with this. So I can actually get rid of this. And let's see how that behaves. So now when I open the light switch and I click close, we detected that window closed and there was no delay. So we're not checking every 500 milliseconds. So there could be up to a 500 millisecond delay before that text changes back. But now we're able to tell right away. There is one slight problem though. When I click the close button in the window itself, that text doesn't change back to open. But when I click the button, it does open the pop-up window again. So it is doing the right thing. It's just that state isn't reflected in our UI. And I thought about this for a little bit, and I realized that it's because of the way Angular performs change detection. So change detection is the process of checking your application state and reflecting any changes in the view. And with Angular, we need some sort of event to happen in order for change detection to run. But since we're clicking the close button in the pop-up window, there's no event happening in the main window to tell Angular that it needs to check that state. So Angular provides us this thing called the change detector ref that we can leverage here. So I'm going to get access to it through dependency injection. And we can tell this component's change detector to perform change detection when the pop-up window closes and the state changes. So I can say this.cd.detect changes. And that should make it so that our DOM updates with the correct text. So now when I open the pop-up and I close it using this close button, cd.detect changes fires, and we're good. Our view is in sync with our application state. So thank you, Brahm, for submitting that PR. That's much better than what we were doing before. So on to the refactoring. When I'm building Angular applications, I like to separate my smart and dumb components into different directories. So I'm going to create a directory routes for my smart or routed components. And I'm going to create another directory called UI for my dumb or UI components. So the first thing I can do is move my light bulb and light switch components into my routes components because those already are smart components. Those are pages that we're routing to and get things through dependency injection, and those components directly change the state of the application. So now we need to pull out some UI components. If we take a look at the application, the most obvious piece of UI functionality that we could pull out is the light bulb. So this thing could be its own component that just takes a state as an input and changes the color depending on that state. We could pull out this open light switch button into a UI component as well. Since it is dynamic, it's changing the text based on whether the pop-up window is open or closed. And we could also pull out this switch button. Right now it's just a button element. If I was going to leave it as a button element, I would probably just leave it in my smart component as is, but I think I want to make this thing a little bit more dynamic. I want to make it look like a light switch. So that makes this a good candidate for a UI component as well. So let's go ahead and create our UI components. I'm going to make a feature module for each of my UI components so that my routed components that use them only have to import the things that it needs. I could just make a UI module, but then both the light bulb and the light switch would be importing everything. So the light bulb would be getting the light switch and the light switch would be getting the light bulb, and that's not really necessary. So let's go ahead and make those modules first. I'll use the Angular CLI and say ngg module light bulb, and I'll say ngg component light bulb with this export flag. So the Angular CLI is smart enough to know that since I'm making a light bulb component and I already have a light bulb module in the directory that I'm creating it in, it's going to put it into that light bulb module. And I'm adding this export flag so that it will also automatically add the component to the list of exports so I can use this component outside of this module. So let's just take a look at this. So the light bulb module declares the light bulb component and exports the light bulb component. And the light bulb component is just your basic component. So let's go ahead and set up the inputs that we need right now. I'm going to say input state can be on or off. And I'll just initialize it to off. So if we don't provide that state input, it's just going to default to off. Now we can create the light switch component and feature module. So I'll do the same thing. GG module light switch. And I'll do this all in one command. And I'll do the same thing for the open light switch button. So let's just first off go ahead and define our inputs and outputs for each of the UI components. So for the light switch, it's going to take an input of state. So the current state can be on or off. I'll initialize it to off. And I'm going to define an output, and I'm going to call this state change, make it an event emitter of type on or off. And a handy little trick to note is that if you have an input with some name and an output with that same name plus change at the end of it, you can do two-way binding. So you've probably used two-way binding on ng model before, where you have the square brackets with the round brackets on the inside. So if you change the value in the parent component, it flows into the child component. And if you emit a change from the child component, it updates the value in the parent component. So that's two-way binding. And now that I think about it, I don't need this open light switch UI component because I'm just going to leave it as a button. So the next thing I'm going to do is I'm going to change the name of these light bulb and light switch routed components because I don't like having the same names in my routes in my UI. So since the light bulb opens in the main window, I'm going to rename this just to main. And since the light switch opens in a pop-up window, I'm going to rename this to pop-up. And I renamed all of the component and module files inside to reflect the name of the directory. So let's start pulling out the UI pieces out of the routed components and put them into the UI components. So in the main component HTML, we've got our bulb. I'm just going to copy it for now. Put that in there. This now is no longer asynchronous. We're providing it through the input, so it should already be resolved by the time it gets to the component. So state to match that input value. And I'll grab the CSS out of here and put it into my light bulb UI CSS. And similarly for the pop-up, I'll copy the button out, put it into my light switch. This is now going to be state change.emit. And I just realized since this is really just a toggle, I'm going to make this just a void event emitter. So I don't have to actually emit a value. It's just going to be an event that says change the state. So now I've got my UI components set up. So I'm going to close everything just to clean this up a bit. And let's replace this div with our new light bulb component. So the first thing I need to do is actually import that light bulb module into my main route module. So I'll do that now. So now I can use the light bulb component. And here I can use the selector app light bulb, and I'm going to pass in our state and resolve it with the async pipe. And I'm getting this error, more than one component is matched on this element, and that's because I didn't change the selector here. And since I'm not using the selector anywhere else, I can just change the value, and that's okay. This component's being routed to, it's not being referenced in the DOM anywhere. So I should probably do that in the pop-up component as well. Cool. And now let's update this HTML to use the app light switch. We'll pass in the state, and we'll react to the state change event by calling flip switch. So this should behave the same as before, but now we're using UI components to render those UI elements. So let's take a look at it, and it looks exactly the same as it did before. And everything works the same. So now these UI components are purely for user interface purposes, and we can reuse them in other components. So if I had another app or another page that might want to use a light bulb, I can just reuse this light bulb component instead of having to re-implement it in my new page component. And I mentioned that this makes it easier for us to test our application. We can write unit tests for this UI component, and all that the unit tests have to do is test the UI functionality. We don't have a combination of test the UI functionality and testing application logic. This light bulb functionality is now isolated to the light bulb UI component. And we can make the light bulb component a little more dynamic. We could add animations to it. We could add a lot more CSS styling without cluttering our route component. So I'm actually going to quickly implement the light switch. I'll probably skip over the implementation because I'm just going to add some CSS and stuff like that. So I've updated the UI a bit of the light switch component. I didn't change the input or the output, so it should still behave the exact same way in the context of the application. But I changed the HTML up a bit, I added some CSS, and now we've got a light switch that has a little bit more style to it. And the best part about this is that now we can reuse this switch in other places. So for a simple application like this with only a couple of elements, maybe this is overkill. But if this application is going to grow into something bigger, you're definitely going to want to structure it this way. As we add more and more UI elements, it's a good idea to separate those into their own components so you can isolate that functionality to one place. And so you don't have a whole bunch of different functionality that's coupled together in the same component. Also, if you're working with a big team, you can get together as a group, decide on all of the UI components that you're going to need, generate them all, define the inputs and outputs, and then everybody can just take a different component, implement that UI component, and you should be able to just plug it into your page at the end when everything's done. So this makes parallel work on a big team a lot easier. You might even want to move these components to some library that you can use across multiple applications. Maybe I'll get into that in a future video. Angular actually provides you a framework for creating Angular component libraries that you could publish to NPM and reuse and share with other people. That's how things like Angular Material or ng Bootstrap work. So just to sum it up, now we've got UI components for all of our UI elements that we want to place on our page. And we have our smart components, our routed components that handle the application logic and rendering those UI components. So I'm going to end this one here. Thanks for watching and see you in the next one.